Okay, so welcome. This is Chapter 2, Section 4. And this is all about dividing radical expressions. Okay, so there are two distinct sections to this. So the first part is dividing radicals with one term in the denominator. Okay, and when we're talking about one term, your terms are separated with a plus or minus sign. So let me show you what I mean. All right, here's an example. That has one term in the denominator. This has one term in the denominator. This has two terms in the denominator. Okay, so this one we'll be talking about in a minute, but notice the plus sign in here. So here's one term, here's the second term, and that's what gives it two terms, all right? So this one has just a radical, this one has a coefficient on the radical, but those both have only one term in the denominator. Denominator being the bottom of the fraction, right? So we're going to talk about how to deal with those, all right, and what you're going to do with them, because when you write a answer to one of these problems, your answer, when written correctly, cannot have a radical in the denominator. Ever. Okay, so we're going to give you a couple strategies to make sure that that doesn't happen, whether you have one term or two terms in that denominator. All right, so let's do a couple of examples. First, we'll deal with something like, we'll take that 8, we'll do exactly what I just had over there, 8 plus radical 2 over radical 7. All right, so if you have only one term in the denominator, your strategy is going to be to multiply both the top and the bottom by the radical value in the denominator. Why? Well, because, so here, why? Okay, if you have the root of x in the denominator and you multiply it by a root of x, whenever you multiply a radical by itself, you get just that value without the radical, right? So in this case, if we go to multiply the root of 7 on the top and the bottom, well, what happens when we multiply a root of 7 times a root of 7? Well, we end up with just a 7 in the denominator. No radical, right? It's the root of 49 technically. Oh my goodness. It's the root of 49 technically. That's so bad. Let me fix that. Okay, so it's the root of 49 technically, but that's 7 and 7. We have a pair, and that's a 7. So if you need to do that to see that that's fine. But you should know that when there's a pair of them, you always get just the number underneath, okay? So now, up on top, you're going to use your multiplying skills that you just had to distribute into here. So we're going to get an 8 rad 7 and a plus radical 14. Sorry, I kind of squished that in there. You need to check and make sure those things are not reducible. Well, this 8 rad 7, a rad 7 is prime. And then a rad 14, its only factors are a rad 2 and a rad 7, and those are both prime. So this would be your answer right here. Okay, I'm going to write it out a little bit bigger, but you'd have 8 radical 7 plus radical 14 all over 7. Now, what you can never do, there is going to be some simplifying here, but you can never divide a number without a radical into a radical. So what I mean by that, you can't divide this 7 here into this radical 7. They're not the same value, right? If you take and put a radical 7 into a calculator, you're going to get like 2 point something. It's not 7, it's 2 point something. A rad 9 is 3 and a rad 4 is 2, so this is 2 point something. A rad 14 is a 3 point something. So you cannot divide this whole number 7 into these radicals, okay? What you can do is if this number, this coefficient was divisible by 7, and you had one here, and you had one here, you could reduce all those. But that's not possible in this problem. So this answer does look like 8 rad 7 plus rad 14 all over 7. Okay, so that is the answer to that problem. All right, let's take a look at another one. All right, so we're going to go 2 rad 3 over rad 20. Okay, well, there's only, first thing you want to check is how many terms are in the denominator. There's only one. So our process is going to be to multiply by what's in the denominator. Okay, well, a rad 20 times a rad 20 is going to give me just a 20. And then I'm going to multiply across on top. So I'm going to get a 2 rad 60. Okay, and then I'm going to have to simplify this thing. So I got to simplify this. So I'm going to do that over here. 2 rad 60. So 60, oh, that's rad 10 and rad 6. The rad 6 is a rad 2 and a rad 3. I'm going to get rid of that. This is a rad 5 and a rad 2. I'm going to get rid of that. So this will come out as a 2. And these two 2's will get multiplied to be a 4. And then these guys will get multiplied and put under here. So that's going to be a 15. So 4 radical 15. So this turns into 4 rad 15 over 20. And now here is an example of where I can reduce a number here. So 4 over 20, 4 goes into 25 times. So this will be 1 rad 15 over 5. And mathematically, you don't need this 1. So it's really just rad 15 over 5. And that's going to be your answer. Okay? That's how that's going to happen. All right. Let's take a look at... Oh, I can do this one on the same page. Super quick. If you see something that looks like this, rad 5 over 6 under one big radical, rewrite that as rad 5 over rad 6, and then just multiply by what's on the bottom. So you can multiply by rad 6 over rad 6, and then multiply here, so you get a rad 30. That's not reducible, we know. And then this is just going to be over 6, so that would be the answer to that. Okay? I know you're going to see something like that, so handle that way. All right, another example. This one with some variables. So we haven't done any of those in a while. Let's see. Oh, and it's under one big radical. All right, so I have 8a cubed. 8a cubed over 3b. Okay, so let's use that strategy I just mentioned. We're going to separate it into a top, 8a cubed over the root of 3b. All right, so there's radicals in it, big deal. We're going to handle it exactly the same way. Multiply by the denominator. Okay, and now I'm going to get a product of those things. So, and they're all under radicals, so 8 times 3 is 24. A cubed b, I can multiply radical or variables together even if they're not like. And here a 3b, rad 3b times a rad 3b is just a 3b. All right, well now I've got to simplify the root of 24a cubed b. Well, 24 is 6 and 4. This is just a 2, so 2 rad 6. And then I have 2 a's will come out as 1, so that'll be there. This guy will stay inside, and this b can't come out. Okay, so I'm going to get a 2a on the outside and a 6ab on the inside. So this is going to look like 2a rad 6ab all over 3b. Okay, so now remember, I can only cancel stuff that's not under the radical, right? So do these have anything in common? No, they do not. So this entire thing up here would be my answer. Okay? All right. So I think that's kind of enough examples on one term in the denominator. Let's do a couple if we have 2 terms in the denominator. I'm going to give myself a couple more slides here, so bear with me real quick. Clone a page, and then I'm going to do another one. Okay, so this is when we have 2 terms. So as long as you can multiply these pretty well, I guess the difficulty is in reducing them. So here's what we're going to do. We are going to use something called the conjugate. And the definition of the conjugate is the denominator with the middle sign changed. Okay, so here's an example. If this was the problem, let's say rad 3 over rad 5 plus rad 6. Well, the conjugate of this is the denominator with the middle sign change. So it would be rad 5 minus rad 6. Okay, and we're going to multiply the top and bottom by the conjugate. So we're going to multiply all right, so I'm going to take that and put that right here times rad 5 minus rad 6 over rad 5 minus rad 6. Now, do me a favor, and whenever you see 2 terms, please put parentheses around them. I'm going to try to squeeze this all in here. I don't know if it's going to work or not. Okay, there's only 1 term right here, so I'm not going to put parentheses around that, but so I'm going to distribute on the top. So this is going to be a rad 15, which I cannot reduce, minus a rad 18, which I can reduce because there's a 9 in it. And then over here, I'm going to do this down here and then hopefully So I've got a rad 5 and a rad 5 is just plain 5. You can put a rad 25 if you need to, and then go from there. Now I've got a negative rad 30 and plus a rad 30. And if you do this right, these two should always cancel out. Okay, and then I've got a minus a 6. So these cancel out. 5 minus 6 is negative 1. All right, well, we can never leave just a negative on the bottom like that. Leading term, I guess. In this case, it's the only term. Okay, so we can reduce this root of 18. So this is rad 9 times rad 2, and that's a 3. So this becomes rad 15 minus 3 rad 2 over negative 1. And what this does, this negative down here changes the signs of everything. So in my next step, I'm going to change the sign on the 15 to a negative. I'm going to change the sign because a positive over a negative is a negative. Now a negative over a negative is a positive. So this is going to be a plus 3 rad 2. And this would be, in theory, over a positive 1. But I don't need that. So now I just have negative rad 15 over 3 rad 2. Okay, and that's how that whole thing would come out. All right, so now let's do one without all this writing all over the page and see what happens. And we're also going to add some variables in there, okay? Maybe I shouldn't add variables yet. Maybe I should do an easier one. All right, we'll add variables into the last one. Let's do, let's go 4 rad 3. I'll do this in black. 4 rad 3 over 5 plus radical 6. Okay, so the conjugate is 5 minus rad 6. Okay, so I'm going to multiply by 5 minus rad 6, 5 minus rad 6, and then I'm going to do that distribution. Remember to put parentheses around anything with 2 terms. And then do the distribution. So this is going to be 20 radical 3 minus 4 radical 18 over, I've got 25 minus 5 rad 6 plus 5 rad 6 minus 6. Okay, so these will cancel out again. I just did a rad 18. What was this? Rad 9, rad 2. So this is a 3. So I've got 20 radical 3 minus 12 rad 2 over 25 minus 6 is 19. Okay, and nothing here is reducible because what I would need to be able to reduce is this number, and this number would all have to have a common factor to be reducible. And that does not happen. So this is not reducible. And so this would be the answer to that. Okay? All right, let's do one more with variables, and then that should be good. Okay, so let's do rad x. Oops. Boo-boo right off the bat. That's good. Okay, so radical x over negative rad x plus 6 plus, yeah, just a plain 6. Okay, so the conjugate, only the middle sign changes, so just this one. So when I multiply this, it's still going to be negative rad x minus 6. All right, this sign stays the same. Okay, so times negative rad x minus 6. All right, so we're going to multiply out here. So this is going to be a negative x squared. Well, negative rad x squared, right? So negative radical x squared, which is just an x. And then minus 6 rad x over, put this in parentheses. So I have a negative rad x times a negative rad x. So a negative times a negative is a positive. A rad x times a rad x is just an x. And then I have this guy times this guy. So that's going to be a positive 6 rad x. And then this one times this one is a negative 6 rad x. And then a positive 6 times a negative 6 is a negative 36. Okay, so I can still simplify this guy. So I've got a negative x minus 6 rad x. These will cancel out. And then I've got x minus 36 on the bottom. Now, a common error. This is your answer, okay? That's your answer. A common error that people want to make is they want to cancel these x's. You cannot do that. Okay? To be able to cancel something, you have to cancel it from every term. Which means there would have to be an x out here and an x in here in order to take an x and cancel one of those out. And then these would become ones. I mean, that's just a little more crazy, but good mathematics says you cannot do that. All right, so I'm going to take those. Hopefully this will work. And I just remove the black x's. Whew, that's what I was going for. All right. Okay, so this is dividing radicals with two terms. Using the conjugate. And this is something that you're going to use again when we deal with imaginary numbers in another section or two. Okay? So hopefully that went okay for you. You're going to get some practice. And again, don't hesitate to come and ask me for help. Please, please come and ask for help if you need it. Okay? Toodaloo for now.